Hello, so here we are with a SAT question. So it's based on a SAT 2021 pattern, in fact. So the question says that a restaurant charges $10 per meal, and at that rate, it sells 200 meals on a day. Now, if it increases the price of the meal by 50 cents, then the number of meals will reduce by 5. So that means instead of 200, it will become 195 meals if it changes the price to $10.50. And in this way, so the question they're asking is, for what price of the meal, of one meal basically, will you have the maximum dollar sales, okay, in a particular day? And those are the options. So we'll solve this question in three different ways, okay? So the first one is we'll just plug in values, okay? So we see that when the price and the number of units, okay, and then we have the dollar sales, right? So the price is $10. You know it's 200 units. The sales is obviously the product of these two, $2,000. Now, what we are saying is, looking at the options, if it is $15, okay, so price has become 15, so you have done plus 5, okay. So we know that for every 0.5, the price will increase, the number of units will reduce by 5, right? So if it is 0.5, then it is 5. So if it is 5, then this will reduce by 50, right? See, I just repeat this once more. If this is plus 0.5, then this is minus 5. Hence, if I just do it 10 times here, so if it is plus $5, why plus 5? Because the first option is that. So here also it will be 10 times, so it would be minus 50, and that would be 150 units. 15 times 150 is 2250. You can use your calculator for this, okay. Clearly this is a higher value, so this is a possibility. Now let's look at 20, okay. So if I have 20 as the price, all right, let's use a different color there, okay. Let's say 20 is the price. So from 10 we are going to measure, right? From 10 we have added 10. So the number of units sold, so for 5 it's 50, for 10 it would be minus 100, and we would have 100 units. The total sales dollars would become again 2000, okay. So we understand that looking at the numbers, see, we started off with 10, we got 2000, we increased it a bit to 15, we got a higher value. When we increased it further, it came down. That means if I increase it any further, it is gonna decrease even more. So we can be sure that obviously 22 and 25, no need to check them. Obviously at 20 the price is lower, so the answer is option A, okay. So this is one way in which we can solve this question, right? Let's look at an alternative, okay. Right, now the second method. So if I look at revenue or the sales, let's call it sales, dollar sales as S, is the price multiplied with the number of units, let's call it U, right? Number of meals sold. And we are saying that initially it was, price was 10, the number of units were 200. And it says that for every 0.5 increase, so let us say I increase X times, okay? I increase the price X times. So if that is the case, then this will become plus 0.5x, and this therefore it would reduce 5 by 5 also x times, so it will become 200 minus 5x. So the number of units here, the price is here, and this is my sales, okay. So this is a quadratic, okay. Clearly if you look at the quadratic, it's a parabolic curve, right? The roots of this, if I were to do, is equal to 0. If I were to solve, okay, it's equal to 0. I want, basically I'm solving for the sales dollar value to be 0. I would get once 200 minus 5x as 0, giving me x equal to 40, okay. And the other one would be 10 plus 0.5x equal to 0, giving me x equal to minus 20. So the two solutions of this quadratic would be one at minus 20, the other at 40, and the graph would be inverted because the x squared term, if you expand, would have been a negative coefficient. So the graph would come somewhat look like this. This is the point where we have the maximum sales. Clearly from symmetry we can say that it must lie between midway between minus 20 and 40. So what's the average? So minus 20 plus 40. So this value is minus 20 plus 40 divided by 2. So that's 10. Okay. So that means at x equal to 10, we will have the maximum. So I'm not interested in what is the maximum. I just need to know that at the price which is 10, okay, at x equal to 10, right? X is the variable right here. So at x equal to 10, I will have the maximum. In that case, therefore, my price will become 10 plus 0.5 times 10, and that will be 15. So that is option A again. Okay, so we don't really need to draw the parabola and all. I was just explaining. So once we get these two as the roots, okay, these are the roots, we should use the logic that the peak, maximum or the minimum, the vertex basically, right, occurs exactly halfway between the roots. So the roots are minus 20 and 40. So what is halfway between the roots? That's 10. So my x value is where we have the vertex. So that value is 10. That's it. So no need to draw all this. So just plug in x as 10 here. You will get the price to be 10 plus 5, $15. Okay. So this is the second way in which we could solve this question. Let's now do a third way. And this is a slightly different approach that we will take. And I'll just quickly explain the idea behind this approach. So the approach is, let's say I tell you that two quantities A and B add up to, let's say 12. When is the product maximum? When A and B are equal to 6 each. See, 6 and 6 if I take, then 36 is what we get. If I take any other combination, let's say like 4 and 8, the product is only 32, which is much lower, right? So the product becomes maximum when A and B are equal. Okay. So we'll use this learning and apply it in this question. So just like the previous case, we will redo that equation. So my dollar sales would be, so it's 10 plus 0.5x times 200 minus 5x, right? Now here, I need a case where the two quantities add up to a constant value, right? Like 12 or something like that. In this case, it clearly does not add up to a constant, right? What I do is I take out that 0.5 from here outside. So this becomes 20 plus x. And I take out that 5 from here. And this becomes a 40 minus x. Now I multiply 0.5 and 5. So I get 2.5 times 20 plus x and 40 minus x. Observe these two terms. Their sum is 60. Hence, the product will be maximum if each is 30, right? Half of 60, 30. If each is 30, that means 20 plus x is 30 or 40 minus x is 30. Either case, I end up getting x as 10. That's the same thing which we had got previously. Once I know that my x is 10, this was my price and this was my number of units, right? So in price, I'll just plug in. So I'll get price to be 10 plus 0.5 times 10, giving me $15 again. All right. So these are the three different ways in which we could have tackled this question. The first method is the simplest one, where you can just keep on using the answer choices to get the answer and plugging in values, right? But the problem is, in this case, it was okay that we got it at the first shot. But if that value was towards the end, okay, then there might have been like, you'd have to do 2-3 trials, iterations, and then you'd have reached the correct answer. Whereas the second method is based on a parabola, quadratic equation, maximum and the vertex form. So that's the fastest way if you can link, okay, by just framing this equation once. If you could frame this equation once, the vertex is very easily obtained, right? So that's the best way. This is slightly different way. So this is something which I would not suggest using it that way, but any of the first or the second methods is fine. Thanks for watching.